we are starting our astronomy unit. This is one of the more interesting units, but one of the hardest units to really wrap your head around. So we're going to start with the really big stuff, the really old stuff, and in order to do that, we're going to try and get your mind in the right spot to think about astronomy. So the stars, space, the universe, galaxies. All right, so this is how we perceive the world, the earth. We're walking on it, we experience it, we look down, we see rocks, but we often don't think about wow, we are on a planet, which is pretty much this ball that is going around the sun every year, and it's spinning on its axis every day. So this is how we perceive the world, right? But it turns out that we are really on this Earth planet, which is this ball, and this is the actual relative distance between the Earth and the moon. So you may think that the moon is super big in the sky, but if you actually go outside and look at it, or try and take a picture of it with your phone, you realize that it's actually really, really tiny in the sky. And that's because it's actually really, really far away from us. But on the grand scheme of things, on the huge universe scale, the moon is not far from the Earth. So just to give you some size understandings, these are the planets in our solar system, and this is the sun. These are their relative sizes. So if you were to shrink them down and keep them all the same difference in sizes, here is the Earth, which is our planet. This is Jupiter, the largest planet in our solar system, and this would be the size of the sun. So the sun is huge. Is it though? So compared to us, compared to the Earth, the sun is absolutely gigantic. You can fit about 100 Earths across the diameter or across the full length of the sun. But to give you some more information, these are stars that are in our solar system, and this little dot right there would be the size of the sun compared to these other stars. So there are huge things out there. Now, all these stars make up this galaxy called the Milky Way galaxy. In our galaxy, we have an estimated about 200 to 300,000, sorry, my bad, 200 to 300 billion with a B, stars in our galaxy. This is the Milky Way galaxy. And in the universe, there are about 300 billion galaxies. So this is our nearest neighbor galaxy, which is called the Andromeda Galaxy. It has about 100 billion stars, and each one of these dots out here represents another galaxy. Each of these dots having about 100 billion stars in it. All right? And this is a real picture of all of these galaxies. This is called deep space. And each one of these is its own galaxy with its own hundreds of billions of stars, and each star having its own group of planets that orbits around it. So really, there's massive stuff out there. So let's put these into size order. Celestial means space. Objects are things, so these are space objects, okay? The smallest of which are going to be comets, asteroids. So these are the icy kind of asteroids that are out there, and then the rocky asteroids. Next is going to be moons. Moons orbit around planets, and then the next biggest will be planets, right? Planets orbit around stars. So stars are pretty massive, and stars make up these collections, right? So the 100 billion stars in one spot, we call that a galaxy. And galaxies and space are the things that make up the universe. And the universe is everything. Everything that's ever been, everything that ever has been, is part of the universe, okay? So, the universe started, or inflated into existence, or the Big Bang occurred about 13.8 billion years ago. You should also know that the Earth is 4.6 billion years old. So that means the universe is 3 times older than the Earth. The universe formed during this process called the Big Bang. So pretty much the idea is that out of energy, or in a way of out of nothing, the universe came into existence. What was there before the universe? We don't know. What happened the moment the universe inflated into existence? It's not totally clear. But we do know that the universe came into existence 13.8 billion years ago, and that was the process called the Big Bang. Matter and space inflated into existence and expanded, and that became the universe. Gravity began clumping things together, and from that, stars and galaxies formed. So the main idea, the Big Bang is the formation of the universe. The formation of the universe was 13.8 billion years ago. And the one piece of evidence that we have for that is this echo of light. So we like to think of echo as being sound, but light can echo or reflect off of a surface, right? So when you look at this board, there is light coming out of this, hitting the board, and then it reflects or echoes off the board into the lens where you can see things. That's why you can see things, because light can reflect off most materials, okay? So in the universe, there is this echo of light that comes from all different directions. And from all those different directions, we can sense that there is this certain wavelength of light called the cosmic background radiation, which is a microwave, the microwave is a type of light. Might be getting into too complicated stuff, but it's a long wavelength, which just means that the light has been stretched out. Main point, what is evidence of the Big Bang? Cosmic background radiation. Cosmic background radiation. Cosmic means universe, or the cosmos. Background just means from all different directions. And then radiation means light. So it's universal light from all directions, okay? And that is proof of the Big Bang. So what is proof that the universe is 13.8 billion years old, or what is the evidence? Also cosmic background radiation. What is the evidence of the Big Bang itself? Cosmic background radiation, all right? So if you take a picture of cosmic background radiation, this is what it looks like. And in all reality, it's hard to understand, but this is a picture of the oldest light in the universe. So this is a picture of the young universe, about 380,000 years after it formed, which is when light first became emitted into the universe. So hopefully that makes sense. Main points are the size of objects. Asteroids and comets are the smallest. Then it goes moons, planets, stars, galaxies, and then the universe is the largest. The universe is 13.8 billion years old, and we have proof of that from this stuff called cosmic background radiation. All right, hopefully that's a nice little intro.